compulsory to answer in a survey, so some responses are just null, they're missing. Now, there are several solutions to this, and I think that the first solution that comes to mind is just dropping the entire column or the entire row. But first, let's see how can we check for missing values. So we have a command in pandas, df dot is null. This is what it gives you. It's a data frame of the same size as our initial data frame, but all the values are in Boolean format. Either they're going to be true or they're going to be false. Now, in this particular data frame, wherever we see true, it means that that particular value is missing, and everywhere that we see false, that tells us those values are not missing. They are present in our data set. So when you add uh, an aggregator to this dot sum, it will essentially tell you this. So the number of missing values, or it will add the number of falses across columns, and it will tell you the number of missing values across each given column of your data set. So for life expectancy for adult morality, we have 10 missing values each, but then there are columns like GDP population where we have 448 and 652 missing values respectively. That's a good proportion out of a data set that is 2938 rows wide. So, like I was saying, the first solution that comes to mind is just dropping rows with missing values. It's not the best approach because in this particular data frame, if I have row 1, and for instance, this one value of life expectancy was missing in row 1, it doesn't really make sense to drop the entire row just because 1 out of 21 values are missing for that row. But let's see what this does for us. Now we know what in place means. If I specify in place equals false, this means my original data frame will not be modified. Rather, it will return a value which I can then save in a new data frame. If in place is equal to true, on the other hand, my original data frame would be modified. So for this particular notebook, up until almost the end, I've kept this parameter as false because I want to be able to um, observe for different kinds of filling or dropping operations without reloading the data frame every time. Anyway, so the command for dropping rows with missing values is quite simple. df.drop_na. This will drop all the rows for which the value is null. I've saved this in another data frame, and let's view this data frame. Now look at the significant reduction in the number of rows. So out of 2938 rows, only 1649 are left now. So essentially, we've just wasted a lot of data, and this is not the ideal solution. Now, if I run the same command on my new data frame, I will observe that there are no missing values, no null values any longer. All right. However, since this is not the best approach, we can modify this slightly. Like, it doesn't make sense for me to drop an entire row if just one particular value out of 21 attributes is missing. But let's say if 15 or 17 out of 21 values were missing, then maybe the best solution is just to drop that row. It's not contributing to my data set as much as I want it to then. So you can apply a simple threshold, and that's how that works. The exact same command, but thresh equals 18. It means that it will drop any row that has at least 18 missing values. And this will improve the size of the data set. So I had 2938 rows initially, out of which 2730 are still left. So this is a better solution. Alternatively, you can also drop columns with missing values. All right, and the command is the exact same, df.drop_na. You have to specify the axis though, axis equals 1. The reason that we didn't specify the axis in the previous command was because by default the axis is always 0. And when the axis is 0, we know that represents rows. When the axis is set as 1, then we're referring to columns. So this command will drop any column which has even a single missing value. As you can see, now we are left with, well, the same number of rows, but only 7 columns. So we had 21 columns initially. I don't think this is a very good way to go as well. Each column has 2938 rows. Each column corresponds to that number. So if only one out of those 2938 values are missing, it doesn't seem very nice to drop the entire column. Data collection is a long, exhaustive procedure and data is valuable. Okay, anyway, you can apply a threshold over here as well. It's quite simple. Thresh equals, and if I specify 0.9 over here, it means that it will drop only the columns for which 90% or more of the values are missing. I could reduce this to zero point 0.6 as well. So if 60% values are missing, drop it. And as you can see, still no column has been dropped. But I could just play around with it and see how that works as well. Even at 10%, I haven't dropped anything. Okay, all right. Moving on from that. Um, Next we have methods for filling missing values. Now, there are two ways to deal with missing or null values. Either you can drop the rows, you can drop the columns with a specific threshold, or you can fill in for those missing values. Now, the choice of method, it really depends on you. So, for instance, if we have a given row for which, like we saw, 18 out of 21 values are missing, maybe the wisest decision is to just drop that row. If we have a column for which 60-70% of the values are missing, maybe the nicest way to go is just to drop that column. However, if we have like 2, 3, 4, 5% of our values missing, maybe a little more, a little less, depending on your specific data set and the problem that you're trying to solve, then maybe we need a technique for for filling those missing values instead. Generally, it's a combination of the two. Maybe I will apply a threshold to drop some rows, to drop some columns, and then with what I am left with, I will fill those with some value. So how do you fill for missing values? We have several techniques over here. An overview of which was given during last week's lectures as well. So you can have mean median mode imputation. The first solution that comes to mind is that you can essentially just fill each missing value with a certain number. You can fill it with anything, but generally we fill this with a useful value. So I have the column of GDP and I want to fill in for missing values. All right, it wouldn't make sense to just fill it with a random value like 10 or 20, but I could fill in all the missing values with the mean of the remaining values in the GDP column, or with the median, or with the mode. I could also just as well use the sum, or, well, the minimum or the maximum, but those are just not as relevant, or that's not really doing anything for me. Anyway, so that is mean median mode imputation. So I will calculate the mean of my GDP column. This only counts non-null values. We're already familiar with this function, and this is the mean that I've obtained. So how do I fill? You will use the command fill NA to fill with any given value. So df, then I specify GDP dot fill NA, and then as the first parameter, because we know what in place means, I'm not going there again. So for the first parameter, you pass whichever value it is that you want to fill all the missing values or replace them with. In this case, df dot mean, I could have just as well written down mode, or I could have written down median, or min, or max, or sum. But min max is not a very nice way of filling these out. Neither is sum for that matter. I would want a value that essentially, in some way, describes the entire column, or the value that the entire column is centered around, which is why mean, median, or mode are used. Okay, moving on. As you can see, for my particular GDP column after this point, hold on, let me see. I would want to do in place equals true over here. So for my GDP column, I have zero null values now, zero missing values. Okay, all right. So this was our first technique. The second technique is forward or backward fill, which is actually pretty simple for that matter. So when we apply forward fill, then whichever value is missing, it is replaced by the value non-null that is right next to it. If right next to it is another missing value, then it's replaced by the one that's next to that, and so on. Similarly, backward fill works in the opposite way to that. So, if a given value is missing, then it will be replaced by the first non-null value behind that value in your given data frame. Generally, when is this a good idea? Now, this is one other thing for us to have a good idea of. So maybe mean median mode imputation can be useful when your missing values are, well, when they're missing at random and maybe the distribution of your data is not significantly impacted by these missing values. So then if you just replace by the mean, the median, the mode, your distribution is essentially going to stay more or less the same. Similarly, forward or backward fill can be a very nice technique when you're dealing with, well, data that is following an order, for instance, time series data. So if you have time series data where you are recording something at regular or close to regular intervals of time, then maybe forward or backward fill would help. It would not change the structure of your data structure much, of your data set much. So let's see, how do we do that? Again, our command is fill NA. The command doesn't change. However, you specify method equals ffill. Ffill stands for forward fill. If you write bfill, it represents backward fill, and that's pretty simple. And this will fill all missing values for all columns of your entire data frame. All right? You could specify the particular columns inside parentheses like we do in order to make this work for only a subset of columns. Okay, lastly, we have another technique which I did want to give you guys a bit of an overview of, although I don't think this was discussed in class, but just so that we know there are other techniques as well. So we have interpolation. This method involves estimating the missing values, and how do you estimate these values? You do so using a certain mathematical equation and the neighboring points. So you use the neighboring points close to the missing value to estimate a value for that exact point. You have different mathematical operations that can be used over here. This is a very nice approach when your data is following a very smooth trend, because then your trend would not generally be disturbed. Okay, let's see. Now, how can we make this work? Fill using interpolation. We are no longer going to use the fill NA function. Rather, you have df dot interpolate. We know what this next parameter represents. In place equals true. Eventually, I've set it equal to true because now I don't mind working with my entire data frame. And well, the method equals linear. We're not going to get into the depth of this method, but essentially several interpolation techniques exist. And that is how you deal with your missing data problem.